Okay, in this tutorial, I'm going to talk you through how to conduct a chi-squares test using a pre-prepared spreadsheet, how to determine your categories and why that's quite important, and also help you interpret the result of a chi-square test in the context of a specific data set and what this actually means. So if we first of all have a look at our data, what are we analyzing in this? Well, we are analyzing whether there is a difference between the number of fields that have a high or low organic content and the number of fields that, in this case, dairy, that have high or low content. So is there some kind of difference in the organic content between wheat and dairy fields? Now, the reason for using a chi-square test is because we are looking principally for there being a difference. It is also a test that is used when you categorize your data. And actually, that is the first thing we are going to have to do with our data set here. We're going to have to turn it into categories. Okay, so let me show you how that works. Up here, we've got the basic table set up for us. And in this case, I've decided to categorize the data into two groups. Okay, first of all, there's two obvious categories. There's wheat and there's grass. And because wheat and grass is nominal data, it's a type of crop, it's not a number, you can see why chi-square is being used, because that's one of the strengths of chi-square. It can be used for nominal data. Now, when you've got nominal data, it becomes important that you are able to count how frequently you are seeing that. So what's the frequency of wheat fields and their organic content? Well, to do that, we have to determine what do we think is a high or a low organic content. Okay, and that is up for us, the person manipulating data, to decide where the cutoff is going to be. Now, in this example, I've decided that fields that have an organic content, or the soil which has an organic content above 15%, will be categorized as having a high organic content. And any fields where the soil sample had an organic content of less than 15% organic, then we're going to class that as being a low organic content. Okay. Now, your cutoffs could be put wherever you want. One of the things you have to bear in mind is that you must ensure that you have at least 5 counts, or a count of 5 values in each of the cells when you do a chi-square test. Okay, so you can't fall below that minimum, otherwise you invalidate the chi-square test. So these cutoffs will become quite important, as you'll see in a second, in actually determining it. All right, so the next thing we have to do is consider, right, how many fields do we have? Wheat fields did have a soil sample which had an organic content of over 15%. Well, if we do a quick little count through this, we can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of the fields had an organic content of above 15%. Okay. How many fields had below? Well, because there's 20 samples, that becomes really quite quick to work out. It would be 9. Okay. So we've got roughly the same number of wheat fields with a high organic content as have a low organic content. But of course, we're not looking for the difference there. We're looking if there is a difference between wheat and grass. So let's do a little count of our grass fields. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 fields have an organic content above 15%, which means we must have 5. Now, this is where the minimum becomes quite important and why your cutoff is quite important when determining how you're going to categorize your data. And sometimes it's quite easy. Like if your categories are males and females, well, there's no dispute between, what is a male or a female, for example. If your categories are ages, people under the age of 20, people under the age of 30, people under the age of 40. Well, once again, there is not likely to be much of a dispute over that. Here, well, I'm deciding what I'm going to call high and what I'm going to call low. And when you decide categories for any data set, you're probably going to underpin that with a bit of data research rather than just come up with an arbitrary decision. But what might shape that is that I have to ensure that I meet a minimum of 5, otherwise I invalidate my result. So for example, in grass, if we have a look at the grass, if we had set our cutoff at 14%, we would have only had 2 that were at 14% or below. And that meant that this would have been 2 and this would have been 18. And that would have invalidated our chi-square test. Right, let's just enter that. Right, now this spreadsheet actually does the calculation for you. It works out this thing called degrees of freedom, which is actually the number of rows of data. We have 2 rows of data. Wheat is our first row and grass is our second row. So that's 2, and then what we do is -1. So that's 2 rows of data minus 1, which actually gives us 1. And then we do how many columns of data do we have? Well, we've got 2 columns of data, and we do -1 on that as well. So it's 2 minus 1. So we end up with 1 times 1, because we multiply the rows -1 by the columns -1. And that gives us 1 times 1 is, of course, 1, which is where this number degrees of freedom comes from. Okay, so that's important. And it's a bit like the n value in Spearman rank or Pearson's test. What we then have to do is find out what our chi-square result was of 20.44. Now, before we look at what that result means, we need to form a null hypothesis. Okay, and this actually should be the first step you do. And the null hypothesis is always that there is no statistical, and in this case, rather than it be correlation, which would be the word you would use for Spearman rank or Pearson's, there is no statistical different, or there is no significantly different, let me rephrase that. There is no statistical difference between the organic content of wheat fields and the organic content of grass fields. So there's no statistically significant difference between the organic content of wheat fields and the organic content of grass fields. So that's the null hypothesis. And what you're trying to do is to see whether you prove that to be true. Is there no difference? Well, our result of 20.44 becomes important. The number in itself is irrelevant, okay? What we need to do is look at it on the chart of critical values. We can see we've got 1 degree of difference, as we're at the top of the table here. And our number, if it is greater than any of these numbers, means we automatically reject our null hypothesis, okay? And because you'll notice our number is bigger than these, let's ignore this last column. That's there, but it's not actually relevant. Let's just deal with these 2. It's larger than this. This is the fact that there's a 95% probability. That's what that number really means, that there is, we can reject the null hypothesis. If our number is bigger than this one, which it is, it's bigger than 6.61, then there's a 99% probability that we can reject our null hypothesis, okay? Which means when you reject the null, you effectively accept what we might call the alternate. Now, the alternate hypothesis is that there is a statistically significant difference between the organic content of wheat fields and the organic content of grass fields. And we are 99% confident that there is a difference. We need to actually report the level of confidence. We're 99% confident. So what does this really mean in plain English? Well, it means when you look at the data, it means that yes, grass fields are far more likely to have a higher organic content than wheat fields, and that we have mathematically proved that to be true. It's not just a freak result, but it's actually mathematically probability. And if we went to another part of the country, we'd probably see the same outcome, okay? What we then want to do is determine, why do we want to know that? Why is there a difference? Now that we've proven it mathematically, why is it? And that is where the geographer comes in to determine what's causing the difference. The maths itself doesn't prove that, okay? So use all of these ideas to answer any questions on how to conduct a chi-square test. And you'll also more than likely be required to consider why you conduct these tests, as well as any potential weaknesses that these tests have, some of which I've already discussed.